Okay, let's tackle gravity, explore number 4. Okay, we're gonna start by drawing our template as always. Make sure you put the date. Draw a margin for writing our thoughts and questions to ourselves, etc. And let's go ahead and write our essential question, which we're going to take from Discovery. What is the difference? What is the difference between center of mass and center of gravity? Okay, so what is the difference between these two things? Center of mass, you have mass, I have mass. It's the amount of material within a given volume of space. And center of gravity. Gravity is your mass multiplied times the force of gravity um, affecting that mass. So if you're on Earth, gravity, Earth has a particular gravitational force based on its mass. If you're on Jupiter, there's a larger gravitational force affecting your mass. So you're going to be heavier. You're going to have a heavier weight. So you have to think about these things. So they could be the same. The center of mass and the center of gravity under certain conditions could be the same, but they also could be different. All right. Well, let's go ahead and write down what we know, okay? Okay. Take a moment, hit pause, write down what you know, write down what you think. All right, well, hopefully you did that. And we're going to start with Roman numeral 1, center of mass. And taking a look at here, they give us a nice picture of the solar system. Take a look at this system. You have all these different objects in there. Where exactly is the center? If I were to ask you, where is the center based on mass? Not based on anything else, just mass. You'd have to think about each of these objects. Jupiter is very massive. Mercury is not so massive. So when you add up all these different things, and they're all in different locations, mind you, some are to the right of the sun, some are to the left of the sun, and don't forget, the sun is incredibly massive itself. Where is the center of all this mass? That's the question we're trying to address. So the center of mass of a system like the solar system is the average location of the mass in the system. That's very useful. So let's go ahead and write that down. In the case of our solar system, comma, the center, I don't know if that's going to write that all down. The center of mass is the average location of the mass in the system. So in this case here, they give us this new equation. There's a lot to unpack here, right? There's a lot of things you might not know. So, well, let's go ahead and take it step by step, okay? We have the vector quantity, which says the center of mass is equal to the sum, this Greek symbol here, the sum initial for all the masses initial times their location, which is a vector quantity. That's why I put an arrow over it, initial. This will all be divided by the sum initial of the mass initial of all the objects in that solar system. Okay, so I guess maybe we should define some things just to help us remember. This symbol means the sum. Okay, and we have the sum initial, the sum initial of the products of the products of each object's mass and location initially. Okay, divided by simply the total, the sum of all the masses, the sum of all the masses. All right, that was a lot to think about. Okay. Now, they're going to say that because the sun is so massive compared to all the planets in our solar system, the sun is so massive that for all intents and purposes, you could say that the sum of the masses initially is equivalent to the mass of the sun. Okay, good to know. Okay. So let's kind of move down here. We're just trying to follow this stuff and we're trying to make sense of this. So here, what they did was they said that the center of the mass of the universe is equal to the product of the masses and their locations divided by their sum of the masses, which you could substitute is the mass of the sun times the location of the sun divided by the mass of the sun. So you could say that the center of the center of the mass of our solar system is approximately equal to the center to the location of the sun. Okay, that's what this is basically saying. So we could say because the mass of the sun is so massive, it is basically the center of mass of the solar system. That's kind of what that all says there. But I encourage you to go back, try to understand what they're saying, try to understand this math equation and formula, okay? All right, we're going to clear the screen there. And, oh, come on. Okay. All right, so let's now, so you're going to have a video here. They're going to talk about weight versus mass. Remember, mass is just the amount of material in a given space. The weight is that mass multiplied times a gravitational force. Okay, and as you should know, your weight is going to change depending on the force of gravity affecting your mass. All right, so now we're looking at this idea of center of gravity. Okay, remember, gravity is going to have your mass times the force of gravity, right? That's going to give you your weight. So the center of gravity of a system, like the solar system, is the average location of the gravitational force on the system. So maybe we should write that down, okay? This will make Roman numeral 2. Center of gravity. It is it's the average location of the gravitational force on the system. Okay? The center of gravity does not always equal the center of mass. You know, that's probably worth making a note of, okay? The center of gravity does not necessarily mean the center of mass. The center of mass. It could be, but it could not. Okay? So one definition of the center of gravity uses the average of the weights of the objects. The weight of an object is simply the magnitude of gravitational force on the object. Okay. I'll let you kind of read a little bit here. But if I were to just kind of move down to the next section here and drill down a little bit, the center of gravity, I have a formula for you here. The center of gravity, which is a vector quantity, that's how we're going to draw a vector sign, is equal to the sum initial of the product of the weight initial. Remember, weight is going to be your mass times the force of gravity times the location initial, which is a vector quantity. So this is a product. These two have to be multiplied times each other. Okay? And then this will be divided by the sum, the initial sum of the weight initial. Okay? So that's how you would figure out the center of gravity. This is the center of gravity. Versus up here where we had the center of mass. Two different ideas, okay? Two different concepts. Okay, watch these videos. They're very helpful. Now, here's this International Space Station problem that I'd introduced a little while ago. Um, you can go ahead and take a look at that. So comparing the centers of mass and the centers of gravity, um, you can see that they've made it equivalent. The center of mass and the center of gravity are equal when the gravitational field is uniform. That's the only time when those two things are equal, is when there is a uniform gravitational field acting on this, okay? We'll go ahead and clear that. The weight of an object is its mass times the magnitude of the gravitational field. We already talked about this. This can vary. This can vary, right? Depends on what planet you are. Clear the screen. And what do we have here? We have the center of gravity is equal to, this might be useful here. Take a look at this equation. They're showing that the center of gravity is equal to the sum initial of the weight initial times its location initial. And then when you take a look at the second line, they actually break that down. Oh gosh, this is really going to be tricky how to keep my pen going. Clear the screen. Go back. Can I do this? I might be able to do this. We'll see, okay? Got my pen. And so I'm not going to be able to write on this exactly and still keep it zoomed in. But notice on the second line, instead of using weight initial WI, they went ahead and substituted the mass initial times the gravity, because that's what weight is. It's your mass times the gravitational force times its location divided by the sum of the, again, they substituted the weight initials for mass initial times gravity. Cancel out the gravity, and what you have is you have a mass initial, the sum of the mass initials times the location initials divided by the sum of the mass initials. And basically what you have is the center of gravity is equal to the center of mass. A vector quantity Rg is equal to the vector quantity of Rc. Okay? That equation there is worth just kind of, I'm just going to put a little thing around here. And I'm going to try to go ahead and say that over here, you could see where Wi is basically equal to the mass initial times gravity. Okay. And that's why you see that substituted. And you see it substituted here, and you see it substituted there. Okay, so I'm sorry, my pen doesn't really allow me to zoom in on here and make that better for you, but that's kind of what it is. Okay. So in this particular problem, comparing the centers of mass and the centers of gravity, they give you this. I'll go ahead and take the time to work through this problem with you guys. Okay, so Roman numeral 3. We have a sample problem. A 6-kilogram object sits at 2 meters west of a 3-kilogram object, and a 4-kilogram object sits at 1.5 meters east of the 3-kilogram object. Find the center of mass of the system. So in this particular problem, the best way to probably draw this is to draw out a number line. And what we'll say is we'll say that 3, this is our 3.0 kilogram object. And we have going west 2 meters. So we have 2 meters. We have a 6 kilogram object. And this is at a location of a negative, we could go ahead and say, instead of negative 2 meters. And then we could say that we have this other object that's 4 kilograms at 1.5. So if this was, so this is going to be at 0 meters. And then this is going to be 1. If this is 2, then this would be 1.5. 1.5. We have a 3.0. This object is 4 kilograms. So how are we going to write that down here? 1.5 meters, positive. We have a 4.0 kilogram object. All right. So where's the center? I think that's what they're asking. Find the center of mass.